Hello, my name is Timothy Muriwa Joseph. In this video lesson, you are going to learn laws of logarithms. And at the end of watching this video, you will be able to apply these laws to solve related problems. So let's begin the lesson without wasting much time. The laws of logarithms. The first law, which states that the sum of logarithms with the same base equals the multiplication of both logarithms, just like what we have here. So we have log A and we also have plus log B in the same base. So what this law says is that we should, since it is positive, we should multiply the log. So that is log A times log B. Let me just give you example so that you will see how to apply this practically. Okay, let's consider an example. For example, okay, let's take example. So if we have log 4 in base 10 plus log 25 base 10 as well, so they have common base now. So since the multiplication law or the addition law says that we should just multiply the log, so we are going to have log 4 times log 25, something like this. So it's going to be log 4. So let's just pick one of the log times log 25. And then, so let's use this page, this side. So we should have log 100, log 100. Then further simplify this, log 10 raised to the power of 2, yes, to make it the same base. So log 10 raised to the power of 2 now. And then this power, this is going, we're going to apply power law, which we're going to talk about later. So this power will multiply the log. So we should have 2 log 10. So yeah, in base 10, log 10 in base 10. Yeah. So now the logarithm of any number to its own base is 1. So since the logarithm is 10 and it's also having the same base, which is base 10, so it's 1. So basically 2 times 1 is going to be 2. So we can say that the value here will be 2 times 1, which is 2. So this is how to apply this law, the addition law here. So this is the addition law, as you can see in the example given. So let's consider the second law. I need to erase the screen. Okay. The second law, which is the subtraction law, the subtraction of logarithms with the same base equals the division between both logarithms. So we have log A minus log B in the same base. So this is just going to be subtraction. That is log A divided by log B, since they have common base. Yes, since they have common base, so we are going to divide. This is what the subtraction law says. Just like the laws of indices, I've talked about the laws of indices, so I have made a video lesson about it as well. So check for the video on my YouTube page, which is titled Pass Mathematics. Pass Mathematics is my YouTube channel, not page. So let's take another example to illustrate this. So let's assume we have log 28. Where's my pen? Can we use green on this? So we have log. Green is not nice. I don't want green. So let's just stick to yellow. Our yellow color is beautiful. So log 28. The base is, let's give it a base 4. Log 28 minus log 14, right? Log, let's do, yeah, log 14. Also in base 4, they have common base. So this is basically equal to, let's just pick one base, log 28, the base is 4, let's not forget, divided by log 14. Yes, this is what uh, the law states. And then to get this done, what do we do here? So 14, we divide this here one times, and 14 divided this guy is going to be two times. So we should have, we're going to, okay, let's come here. So we're going to have a log 2 now in base 4. And then you can further simplify. So to simplify this, just equate it with any letter of your choice. So I'm going to pick x here. Okay. So so we are going to have log 2. The base is now going to take the value of the x and then to make the work simple and then equal to the log itself here. Then we have we can use for that. I think this space is okay. So we have 4x raised to the power of x rather equal to 2. And then let's make it the base to be 2. So which we are going to have 2 raised to the power of 2x equal to 2 raised to the power of 1. So these 2 cancel this 2. And then we have 2x equal to 1. Therefore, if you divide both sides by 2, we should have our answer as 1 over 2. Okay, I need to put this. The equal sign is not here. So 1 over 2. So this is how to apply this the subtraction law. It's so simple, you can see. Let's move to the next one. Clear the screen. So, which is the third law? This third law states that the exponents of a logarithm also multiplies itself. Yes, the exponents of a logarithm just also multiplies itself. Exponents, another word for exponents is index. Yes, index or power. Okay, so don't get this twisted. This means power. This means also index. So I can use index. I can use exponents and or power. So let's look at the log that we have. So this is log a raised to the power of n. So the power will multiply. This is the power law. So the power will multiply the log itself. So it multiplies the log. So let's take an example to illustrate this practically. So let's assume we have a log, a given log 8, which is raised to the power of 3. Let's make the base to be 2, is in base 2. Now, do we have, okay, let me bring this here to save space so that you can consider maybe like 2 examples here. So example 1, let's say example 1, we have log 8 raised to the power of 3 in base 2. So here to simplify this now, so what the law say, this law says is that we should multiply the log by 3. Yes, since the power of the log is 3, so we are going to simplify, and after we simplify, we are going to multiply whatever answer we get by this 3. So let's express this as 3 log 8 in base 2, log 8 in base 2. Yeah. So to simplify now, so let's not forget this 3. So we're going to put this 3 in a bracket, then we equate this now. So this is going to be 2 raised to the power of x to find the value of the log equal to 8. And then we are going to make this to be in base 8, base 2, since the lowest base here is 2. So let's not forget our 3 that we have isolated. So we have 2 raised to the power of x equal to 2 raised to the power of 3, right? So yeah, so this take care of this, they cancel. So we have our value as 3, which means the log is 3. So we can now say that 3, therefore we say that 3 multiplied by what the answer we got, which is this. So 3 times 3 multiplied by the log. So and we should have 9. Is this correct? Yes. So we have 9. So this is how to apply this law, the power law. Let's take another example. Can I use another color? Let's see if red goes on this. Oh my goodness, red. Okay. No. Do I like this red? No, I should just change it to white. Okay, so let's take another example. If we have let's say we have log, what log are we going to use? Log 9. Should we use log 9? Okay. Log 9 raised to the power of half in base 81. In base 81. Yeah. I don't like this red color. I'm going to change it. Let me change it to white. So log 9 is to the power of half in base 81. Just as the law states, we multiply the power of the log, multiply the log by its power. So here we're going to have 1 over 2 multiply, is going to multiply this log, log 9, right? In base 81. Okay. Then let's try to isolate this guy. Let's not forget, and then we equate this value. So just put x or y. Okay, I'm going to use y here. 81, or I use, that is the base, the log is 9. I'm going to use y. So let's look for y too. We're tired of looking for x. So we have a half. So let's isolate it. We are going to have 81 raised to the power of this y equal to 9, and then we make them to have common base, and the easiest way of doing that is to use 3. So let's not forget our friend, which is a half. Just multiplying the log. We have 81. So this is going to be 3 raised to the power of 4. Yes, 3 times 3 times 3 times 3. Am I correct? Yep. 3 raised to the power of 4y equal to 3 raised to the power of 2. Yeah. So this we cancel this, and then we are left with 4y equal to 2. So bracket 4y equal to 2. So let's deal with this. So our answer is going to be 1 over 2 times 2 over 4, if you want to do it this way. 1 over 2, because we divide both sides by 4, it's going to be 2 over 4. So this 2 cancels itself, and then we have 1 over, 1 over 4. Yes, we should have 1 over 4. It's correct mathematically. Yes, there's no blunder here. So you can see how we tackle this, how this is solved. So this is how to apply this power law, which is the third law. Let's move on to solve another problem. We need to erase the screen. So that takes us to the fourth law of logarithm. So firstly, I need to clear the screen. So the fourth law, which is the power of the base, says that when it is the base that has the power, the reciprocal of this base is used to multiply the logarithm. Don't forget the power law says that we use the power of the log to multiply the log. That's is the third law, and then we have done that. You have considered examples on how to apply the law. So, but here the fourth law, which states that, which is the power of the base, it says that when it's the base that has the power, the reciprocal of this base is used to multiply uh, the base, not multiply the. So, although it is mathematics, but this needs to be correct, so I need to change this to multiply the base. So this is why, beg your pardon. So the logarithm rather. So when it is the base that has the power, the logarithm, the reciprocal of this base is used to multiply the logarithm. So let me just write it here for you to see. So let's say we have log. What this means is that when you have log, certain log a goes to the power, not log a rather, the base is a, but we have log x in base a, and then the power is 2. So what this law states is that we are going to multiply the log by the reciprocal of the exponent, which is this, since it is the base that has the power here. So what is the reciprocal of 2? The reciprocal of 2 is simply 1 over 2. So we are going to have 1 over 2, which is half, multiply log x in this. Okay, simple. Okay, let's take example. Can we do 2 examples here? Looking at the space that we have. Okay, let's just take just one example. I think it is going to be enough to illustrate the law. So let's assume we have a log, maybe it's log 16, huh? Log 16, okay, log 16 in base 2, and the base is raised to the power of 3. Okay, so we are going to apply this law now. Since the base is one that has the power, the law says we should multiply the log by the reciprocal of the power of the base. So we are going to have 1 over 3. The reciprocal of 3 is 1 over 3 as well. Multiplies log 16 in base 2. Yeah. And then let's simplify now. So we simplify this log 16 now in base 2, and then we come back later to multiply whatever we get by 1 over 3. So let's not forget this guy. So to do this, just equate this to a certain letter. So let's say log 16 in base 2 equal to x. Then we are going to have log 2 raised to the power of x equal to 16. So we simplify this guy. Let's come here. So we have 2 raised to the power of x equal to let's give this the base 2 too. So it's going to be 2 raised to the power of 4. Yes. Therefore, we have this cancel this. So our x is 4. So that means log 16 in base 2 raised to the power of 3 is 4, or log 16 here is 4. Then we multiply it by this. So let's multiply it by the reciprocal times 4 now. what do we have? So we should have our answer to be 4 over 3. 4 over 3. So this is how to solve this problem. Let's take another problem and solve. This is one. We have enough space. I need to change this. So let's take another problem. Oh, green works. Goodness, I love green. No, this is B. I've done another example. So if we have our log 27, log 27 in base 9 raised to the power of half. Yes. Since this power of the base says we should multiply the log by the reciprocal, then the reciprocal of 1 over 2 is 2 now. So we're going to say 2 multiplies log 27 in base 9. Yes. Then we find log 27 now and we multiply the value by 2. Okay, so let's go. So we equate this. So log 9, no, how am I saying log 9? Log 27 base 9 equal to, let's use A in this case. So we have, let's not forget these two. So if you can choose to put in the brackets, we just keep writing it. So let's put in a bracket this one number. So we have a 9 log, oh, this space will be enough, log 9 raised to the power of, no, log 27 raised to the power. So we put the power here, rather. So equal to the log itself, which is 27. So the base is 9. So let's not forget our power. So we are going to have 9 raised to the power of A equal to 27. Okay, let's go. Then let's give these two numbers the same base now. So this is going to be 3 raised to the power of 2, and this is going to be 3 raised to the power of 3. So we have 3 raised to the power of 2A equal to 3 raised to the power of 3. So these 3 cancel this one, and then we're left with 2A equal to 3. So I'm bringing this guy down. 2A equal to 3. So here our A should be 3 over 2. Yes. So we are going to have 2 times, that is this 2 times the value of what you are getting in, so which is going to be 3 over 2. So this 2 cancel this one, and then we have our answer as 3. Yes. So the answer here is 3. Okay, this is how to apply this fourth law. It is very simple to apply. Another law that is very simple is, which I've talked about, logarithm to its own base. So remember that the logarithm of any number to its own base is equal to 1. Log 10 in base 10 is 1. Log 8 in base 8 is 1. Log A in base A is going to be 1. So any log which is in its own base, it is 1. Don't forget this. And then another law of logarithm is that the logarithm of 1 is always 0. Please. The logarithm of 1 is always 0. I'm not going to give an example here because you just need to remember this. And if you want to prove it, you can do your research, but I think it's just 1, 0 rather. The logarithm of 1 is 0. I'm not giving an example, but it's simple to remember. So remember these laws. They are going to help you in your calculations of logarithms. I'm going to do another video lesson where I'm going to solve different problems in logarithms. So please subscribe to my YouTube channel. You're going to learn a lot, and try to like my video. I'm also persuading you to make comments. Let's get connected together. Make comments, express the view, what you think about my lessons, and then that's going to encourage me to do more and give you the best. Thank you for taking your time to watch the video. Goodbye.